Hi guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physics in detail, and my courses are going to help the students who are preparing for CSIR NET, GATE, SET, Jest, TIFR, uh, NT exam, PhD exam, IIT-Jam exam, and other exams related to physics. And thank you so much guys for subscribing my channel, and also I would request the people who haven't subscribed my channel yet, please subscribe my channel. So today we are going to study mathematical physics, and this is the lecture number 2, and we are going to start now. Okay, just let me check. Okay, so we are going to study gradient today. Okay, gradient of phi we're going to study. Okay, let me just check, is my connection okay? Yeah, my connection is okay. Okay, so we are studying gradient of phi today. So I'll take the example. Suppose we have been given the equation of surface or level surface, that is 2x square 2x square plus yz plus z square x. Okay, this is given, and so we have to find gradient of phi. So it is going to be gradient of phi equal to, we know the value of del, right? Del over del x I cap plus del over del y j cap plus del over del z k cap, and into phi, that is 2x square plus yz plus z square x. Okay, so now we are going to solve it. So it is going to be uh, 4x, and we'll multiply del x with this first. Okay, and this is going to be 4x, and there is no no term of x, so it is going to be 0. So it is this is going to be uh, z square I cap. Okay, plus now we'll operate this with phi. Okay, so this is going to be uh, there is no term, right, of y, so it is going to be 0. This one is z, and there is also no term of y, so z j cap plus, we'll operate this one with this. It is going to be, this is 0, there is no z term, and there is z, so it's y plus 2xz, right? So gradient of phi is going to be this one. So 4x plus z square I cap plus z j cap plus, this is k cap. Okay, k cap plus y plus 2xz k cap. This is very simple, you know it, right? Okay, so this is the gradient, right? Now I will explain the physical meaning of gradient. Okay, Physical meaning of gradient. So gradient of phi, the physical meaning of it, the direction of maximum change, direction of maximum change in perpendicular direction, perpendicular direction, perpendicular direction to the level surface, to the level surface. Okay. So the physical meaning of gradient phi is direction of maximum change in perpendicular direction to the level surface. Okay, perpendicular direction to the level surface. I'll explain here. So this is like, suppose we have given level surface. This is a level surface phi, right? And now we need to find out the gradient phi. So this is going to be, okay. So this is going to be perpendicular. Okay, let me just. This is a straight line, guys. Okay, perpendicular makes 90 angle with this. Okay, perpendicular to the level surface, that is gradient of phi. So this is the physical meaning. So if we have been given any level surface, the perpendicular to the level surface is called gradient of phi. Okay, so this is the physical meaning. Now we'll write second is directional derivative. Okay, directional derivative, directional derivative. So directional derivative of vector is going to be gradient of phi dot a cap. Okay, so directional derivative of any vector is where A is a vector, so that is gradient of phi uh, dot a cap, or we can write gradient of phi dot vector A upon mod of vector A, because we know a cap is vector A upon mod A. Okay, guys, so this is the directional derivative. So directional derivative. Okay, now now we will write equation of plane. Okay, just let me check. So there are many questions which are asked in NET, GATE, IIT-Jam and other exams related to gradient. Okay, which I'm going to solve today for you. Okay, so this is so we can easily find out directional derivative, right? If phi and a is given, so easily we can find out directional derivative is gradient of phi dot a cap or gradient of phi dot vector a upon mod a. Okay, so now equation of the plane, this I'm going to do in next page. Equation of plane, equation of plane, equation of plane. Okay, so there is a formula for equation of plane which I'm going to write. Note down this: x minus x1 del del phi over del x at any point p plus y minus y1 del phi over del y at any point P, okay, and then z minus z1. Very important formula. Many questions has been asked so far from many examinations related to physics. Okay, okay. So this is del phi over del z at any point P. Okay, that is equal to 0. This is the equation of tangent plane. Okay, equation of tangent plane. This is correct here. Very important formula. Okay, because many questions have been asked. I will solve questions as well. And similarly, we can find equation of tangent line. Okay, this is equation of tangent plane. Equation of tangent plane. Sorry, tangent line. Tangent equation of tangent line. Equation of tangent line. So this is x minus x1 upon del phi over del x at P equal to y minus y1 upon del phi over del y at any point P equal to z minus z1 upon del phi over del z at any point P. Okay, these are a very important formula. You need to note down. Okay, now we are going to solve question. Okay, which are asked in GATE, NT exam, SET exam, NET exam, etc. So I'm writing the question. I'm writing a question as example. Okay, and similar questions has been asked in CSIR, NET, GATE, IIT-Jam. Okay, so this is question is the equation of plane, equation of plane, that is tangent to the surface, tangent to the surface x square plus y square plus z square equal to 0 at point 1 1 1. Okay, you need to find out the equation of plane, that is tangent to the surface this. Okay, equation of plane, that is tangent to the surface this at point this is, this you need to find. Okay, so I will solve this question by two methods. Okay, one is I will apply I will use the formula. Another I will use gradient of phi, and I will solve the question. Okay, the first method method first method is, so surface is given. Suppose this is the surface which is given. Okay, and this is the surface given, and this is the plane. This is the plane which is tangent to the level surface at point 1 1. This is this point is O, and coordinates are 1 1 1. Okay, okay, and yeah, and this is the level. This is the surface whose equation is x square plus y square plus z square given. Okay, so now we need to find the equation of plane. Okay, since phi is x square plus y square plus z square, this is the equation of surface or level surface. Okay, so now we know, I have already explained, the gradient of phi is normal to the level surface is called gradient of phi, right? I have already explained. So what I will do is I will take normal at the point O. Wait, actually, this is a straight line. Okay, this is straight line, guys. Okay, so this is gradient of phi. Phi is given. This is gradient of phi. Okay, so at point this gradient, so this is the normal to the level surface, we know. Okay, for finding the equation of plane, we'll take any point P here. Okay, and we'll consider uh, the coordinate of P are x, y, z. Okay, so now we'll join the line. We'll join the point P from O. Okay, this is straight line, guys. Okay, this angle is 90. Consider this these are straight lines. Okay, so but these are not looking straight, but these are straight line and perpendicular to each other. Okay, okay, so now we know, we can easily find out the equation of plane. How? We can say this is OP, and we can say this is OQ. Okay, okay, so we can easily find equation of plane because this angle is 90. It means vector OP vector OP dot vector OQ. Vector OP, sorry, vector OQ dot vector OP is going to be 0 because angle is 90, right? So because we know A dot B equal to AB cos theta. Here cos theta is 90, cos 90 we know 0. By this we can easily find out the equation of plane, right? So now I will solve it. This is the actual meaning, physical meaning of gradient. Okay, so now we'll find gradient of phi. Okay, so that is going to be del over del x I cap plus del over del y j cap plus del over del y j cap plus del over del z j cap. Okay, into phi. The value of phi is this one. x square plus y square plus z square. X square plus y square plus z. Very important question, guys. You will get these type of questions, same questions in NET of 3.5 marks. Okay. Now we'll solve it. So it is going to be, we'll operate this operator with this phi. So this is going to be 2x I cap plus 2y j cap plus 2z k cap. Okay. So gradient of phi. Now we'll find gradient of phi at point 1, 1, 1, right? So we'll put the value of x, y, z here. It is going to be 2 into 1 I cap plus 2 into 1 j cap plus 2 into 1 k cap. Okay. So it is going to be 2x I cap plus 2, sorry. Okay. 2 I cap plus 2 j cap plus 2 k cap. Okay. So this is the gradient of phi at this, right? Now we'll find OP, the vector OP. Here you can see this is OP, the coordinates of OR 1, 1, 1 and P is x, y, z, right? So vector OP is going to be x minus 1 I cap plus y minus 1 j cap plus z minus 1 k cap. Okay. And now we'll find OQ, vector OQ at 1, 1, that is gradient of phi at 1, 1, right? That value we have already found, and this is 2 I cap, 2 j cap, 2 k cap, right? We'll write 2 I cap plus 2 j cap plus 2 k cap. Okay. So implies, therefore, the vector product, vector OP dot OQ, right? This is going to be 0. Vector product is commutative, right? So we can write OP dot OQ or OQ dot OP. Both are same. Okay. So implies, we'll write the value. This is x minus 1 I cap plus y minus 1 j cap plus z minus 1 k cap dot 2 I cap plus 2 j cap plus 2 k cap implies we'll do dot product. So it is going to be 2 into x minus 1 plus, you know, dot product, right? I'm sure about it. Right. So it is going to be 2y minus 1 plus 2 2z minus 1 equal to 0. Okay, so it is going to be 2x plus 2y plus 2z equal to 6, right? So this value is going to be, implies x plus y plus z equal to 3. Okay, this is the answer. This is the answer, and we have solved this equation using definition of gradient. Okay, this one, because gradient is normal to the level surface. Okay, so now we'll use second method. Second method. And here we are going to write. We will use formula, right? We know the equation of plane, that is x minus x1 del over del x at p plus y minus y1 del over del y at p plus z minus z1 del over del z at p equal to 0. So we'll write the we'll directly put the value. So x minus x1 points are given, right? These are the points 1 1 1. So this is going to be x minus 1 and del over del x at p. So this is del phi, guys. Del phi over del x, del phi over del y, and del phi over del z, right? So we'll differentiate del phi with x with respect to x at point p, right? So this is going to be x. So it is going to be 2x, right? If you differentiate phi x square plus y square plus z square with x, it is going to be 2x, and if you put the value 1, so it is going to be 2 into 1, right? So this is going to be 2 into 1 plus y minus 1. This is also going to be 2 into 1. We'll we will differentiate phi with respect to y at point 1 1 1 1. Okay, this is going to be 2 into 1. Similarly, this is going to be uh, z minus 1 into 2 into 1 equal to 0. So it is going to be implies x plus y plus z minus 1, sorry, minus 3 going to be 0, right? Because 2 2 will go right hand side and become 0. So implies this is going to be x plus y plus z equal to 3. This is the answer, right? So this is very simple. We have used just formula and solved it, but you need to know both the method, right? Okay, guys, we'll solve next question now. Okay, so now I'm going to solve some questions of CSIR, NET, GATE, and IIT-Jam. Okay, which are based on the gradient and whatever I have taught till now. Okay, okay. So let me just check the question. Okay. This is the question. Which is asked in NET JRF June 2012. Okay, so this is asked. This is the NET question, NET JRF question asked in June 2012. Okay, so question is a vector perpendicular to